example 2 and part A, we need to sketch this graph. And of course, you can already see that we have three brackets here, namely because this one is repeated, x minus 1, x minus 1, x plus 1. And obviously, when this is equals to 0, then we can get the critical values. X is equals to 1, x is equals to 1. This is a repeated root. X is equals to negative 1. So you will see the graph of the function given. The critical values are negative 1 and 1. But of course, 1 is repeated, so it touches and leaves. But it is important we consider when x approaches negative infinity, y approaches what? And in this case, our value of x, to evaluate what happens to y when x is negative infinity, is going to be negative 2. To the left of negative 1, you can see negative 2 minus 1 is minus 3. Negative 2 minus 1 is another minus 3. And negative 2 plus 1 is a negative 1. So this is obviously negative 9. So as x approaches negative infinity, y approaches negative infinity as well. So as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, how does y behave? And for us to see how y behaves when x tends to be positive infinity, we need to consider the value of x is equals to 2. And this bracket 2 minus 1 gives us a 2. 2 minus 1 gives us a 2 in the second bracket. And 2 plus 1 gives us a 3. And of course, this is 4 times 3, which is positive 12. So as x approaches positive infinity, y also approaches positive infinity. And we are talking of, but we must take care of this particular point, because x is equals to 1, x is equals to 1, it is actually a repeated rule. So you can see it's going to touch there and leave. So this is the graph of example 2, part A. But if you want to talk about example 2, part B, we must look at this function, and all of them have x, and therefore we must factor out x and have x squared minus 2x minus 3. You can already see that the bracketed part becomes a quadratic equation, and we must deal with it as such. And therefore, we're going to have x squared, AC is minus 3 and B is minus 2. So when we are talking about minus 3 times 1 is minus 3, and minus 3 plus 1 is minus 2. So plus x, the factors are minus 3 plus 1. Those are the factors, and you can interchange them. There is no problem. Minus 3x minus 3, if this is now the extended version of the quadratic function, so this one alone gives us x plus 1 minus 3, x plus 1. And at the end of the day, we have three brackets written as x minus 3, x plus 1. And at that point, we need to x minus 3, x plus 1, x. We need to have the critical values as, of course, this is an independent bracket. When we consider all of this to be 0, then x can be 0, x can be 3, x can be negative 1. Now, we need to just highlight and talk about x being negative 1, x being 0, and x being a 3. This is a 0. Examining this as x tends to be negative infinity, how does y behave? And with this, we are talking of when as x tends to be negative infinity, how does y behave? If we talk about negative infinities, therefore we must consider x being a negative 3, and the first bracket gives us, not negative 2, even negative 3 can work, but let's just use negative 2. The first bracket gives us negative 2, the second bracket gives us negative 5, and the third bracket gives us a negative 1. So you can see this one is tending to be negative 10, so y tends to be negative infinity. So we are talking about as x tends to be negative infinity, y tends to be negative infinity. As x tends to be positive infinity, let's say a 4, the first bracket gives us a 4, 4 minus 3 is a 1, and 4 times 1 is 4, 4 plus 1 is a 5. 4 times a 5 is positive 20, and y tends to be positive infinity. So as x tends to be positive infinity, y also tends to be positive infinity. So our graph looks like that. And that is our graph as far as part B is concerned. But let us just in a special way consider part C. And if you look at this, part C is a repeated root 3 times, because we can write it x minus 2, x minus 2, x minus 2. So there is only one root, there is only one possible value of x, which is a minus 2. And therefore, we would wish to just have x being equals to 2, and the graph cuts the x-axis at that particular point. But assuming that x is 0 for that matter, when x is 0, we have the whole of this bracket being equals to minus 2 cubed. The graph also passes through the coordinate 0, negative 8. But how does the graph behave? Of course, you can see when x tends to be negative infinity, already y tends to be negative infinity. What about when x tends to be positive infinity? As x tends to be negative infinity, you can see when we considered x to be 0, because 0 is to the left of 2, y tends to be negative 8. So as x tends to be negative infinity, y tends to be negative infinity as well. As x tends to be positive infinity, let's say a 3, this bracket itself talks about 3 minus 2, which is a 1. 1 cubed is a 3, is 1 rather. 1 cubed is 1, so y tends to be positive infinity. So you'll have a graph that talks about such a shape. And it is true, you can see that this graph cuts the x-axis only 1. So that function has only one root, which is repeated 3 times. This graph cuts the x-axis 3 times. So that graph has solution, 3 solutions, which are quite quite independent, 0, 3, and minus 1. And this graph cuts the x-axis at 2 points, which are the solutions, negative 1 and positive 1. But most importantly, it is the shape of the graphs that we have been able to sketch. And with that, we come to the end of example 2. I hope this is clear. Please follow and understand. All right.